So it's my privilege this morning, this afternoon, this evening, depending on your time zone, to introduce and welcome Dr. John Rogers, M0JAV. John's currently chair of the RSGB EMC committee and has been a volunteer for the RSGB for over 10 years by my calculations and what I've read, occupying a number of roles in that capacity. He's conducted many investigations into RFI from new technologies and in particular VDSL. And whilst working at Raycal Electronics, he specialised in signal processing for radar and radio electronic warfare. His radio amateur interests are about searching the bands for unusual signals and propagation. And I guess I should say that whilst the legislation that John will address in his presentation this afternoon is UK-centric, my understanding that other countries are also beginning to consider similar exposure assessments, and I'm sure the principles for safety and other reasons will be of wider interest too. During his presentation, John's going to be addressing some specific questions that have been submitted to him, and he's allowing 20 minutes at the end for further questions. So please do submit those in the Q&A channel. And so without further ado, I'm going to spotlight John for everyone. And John, it is over to you.
Okay, I've got host disabled participant screen sharing on my screen.
Let's see if we can. I've adjusted that, John, so...
Thank you. Hopefully you can see the screen.
We can indeed.
And with a bit of luck, you can see the presentation. So thank you for the introduction. One of the things that Nicholas said, which is quite true, is that the physics is the same no matter what country you're in. Unfortunately, different countries choose to use different limits. Ofcom have chosen to use EMF limits. And as many in the UK will know, we're all required to check the EMF levels to determine what we call exclusion zones, which is places where people should not be because the exposure limits might be exceeded. And you're required to do this for frequencies above 110 megahertz by November the 18th this year. I'm just going to put the laser pointer on. So, okay, so how do you do it? This is the simple way, particularly for the higher frequencies. You can demonstrate one of three things. You can either show that you're low power assessed and compliant, and that means that you're less than 10 watts EIRP and less than 100 watts EIRP peak. So it's 10 watts EIRP average and 100 watts EIRP peak. Or you can make sure that people can't get into any exclusion zones you find. Or if people can get in, you can use control measures to make sure nobody's actually there when you're transmitting. So three very simple ways to achieve compliance. So what's the new license condition all about? Our bodies are very good at removing excess heat by blood flow, sweating, panting, etc. But if the heat generated exceeds the body's ability to remove heat, then overexposure can start to lead to harmful effects. And radio frequency will warm body tissues. So what you've got to do is make sure that the power that's going into the body is less than that can cause harmful effects. So there are two types of restrictions. There's the basic restrictions, which determine health effects, but are very difficult to measure. Then there are reference levels. These are electric and magnetic field levels that correspond to the basic restrictions. So if you can keep your electric and magnetic fields below the reference levels, then you will be compliant. There are two types There's general public and occupational. ICNIRP and Ofcom only use general public. And then there are two types of exposure, local and whole body. And this has to be done for peak, average for 6 minutes, and average for 30 minutes. Now, what we tried to do in the RSGB is to find a simple way of helping you to do that without having to understand it all. So the first thing to understand is what's an exclusion zone. It's an area around your antenna where the reference levels may be exceeded. Anywhere outside of that is a compliance zone, and you will not cause harmful effects or go against your license condition. Now, the boundary shape and type obviously depends on the antenna, but the principle's the same. And the most important message today just flashed up in red. If no one is present in an area, then they can't be exposed. So if you make sure that nobody is there when you're transmitting in any area which could be an exclusion zone, then you can't have any problems. The reason why there are two types of averaging and peak limits is the two types of averaging are for local exposure and whole body exposure. And there is a secondary effect called electrostimulation, whereby peak fields can cause your hands to twitch or your nerves to, you can feel it. So how do I comply? Basically, you need to do compliance checks and keep records. There is a very, very simple one, which says if you don't turn your radios on, and you can certify that you don't turn them on, then you don't need to do the compliance check. Or if you only use bands where your power permitted by your license is below 10 watts EIRP, then the job's finished. But ignoring that, the step 2 is to carry out a compliance check. And you can see various different ways of doing it here. You can use either the ICNIRP 98 or the 2020 limits. The Ofcom calculator uses ICNIRP 1998, and it gives a single distance as a compliance distance. The RSGB calculator, which I'll demonstrate very shortly, includes the other factors that affect the power out of your transmitter before it gets to the antenna. That's transmission modes, feeder losses, antenna gains, and directivity factors. They can all help you derive your exclusion zones. There's an even simpler way when the papers exist. You can use a pre-assessed equipment configuration, and that we're doing a number of these at the moment, and I'll be talking about one for VHF and UHF rotatable antennas. And what these do is, by loads and loads of modeling, thousands and thousands of runs, we've been able to come up with limits that if you stay the right side of, then you will be compliant. Unfortunately, we've only done 2 types so far, and there are lots more to do. And then you can use any other method you're confident in, and you can defend if Ofcom asks you the question. There are lots of other calculators out there. I would just warn you that if you've got to make sure that you're using one that is compatible with the current Ofcom limits in either ICNIRP 98 or 2020, which is general public limits. A lot of them use occupational limits or use FCC or IEEE or somebody else's limits, and they will not give you compliance with Ofcom. Step 3, if you need to, manage your compliance by keeping people out of your exclusion zones. And step 4, which you will have to do, keep a record. Now, I haven't put in here the fact that you could go out and take measurements. The reason for that is that we actually believe that it's far simpler to use the calculator or a PAEC. If anybody does want to go out and take measurements, one of the few procedures or processes that Ofcom have mentioned as an approved one is ITU-TK61. So if you look up ITU-TK.61, then you'll see how complicated it is to take the measurements. So let's have a look at the handheld. And one of the questions I had pre-submitted was, explain the difference between EIRP and ERP and PEP. So we start off with just watts, PEP if you like, and that's the power coming out of your transmitter and your linear amplifier. We then look at any averaging reduction in that in the first column. In the second column, we look at the losses from the feeder, and we're still working in watts. However, as soon as we get to the antenna and we add on the antenna in dBi, decibels relative to an isotropic antenna, then we end up with the power coming out in EIRP. So EIRP is the power you put in, averaged by any average power levels from your thing. So if you put a meter at the output of your transmitter running FM 10 watts on 2 meters, transmitting half the time, then you'd expect the meter to read 5 watts, whereas the peak level is 10 watts. You then need to take off that the losses from the feeder. In this example, there aren't any because I put a 0 length cable in. And what you end up with is a power going into the antenna, add on the gain or multiply by the gain if you're working in linear, take off any extra losses, and you end up with 8.2 watts, average 16.4 watts peak. And you may notice that that is compliant. So we've actually got a trap in the calculator that if you have a situation like this, which is a typical 5-watt handheld, then it comes up with a message compliant, no further assessment needed, as the average power is less than 10 watts EIRP and the peak is less than 100. You need to fill in the yellow boxes, and I've been through those. The calculator gives the average power, and one of the other questions is, why do we specify the transmit in 6 minutes? How much percentage? Well, you're only heating the body, which is integrated over a 6-minute period for local exposure, for half the time. So you know, if you run your microwave for 1 minute, your food will get half as hot as if you run it for 2 minutes. So that's 2 questions answered, I hope. And why 6 minutes? Because that's what it tells us to do. So let's look at a slightly different version. This is the RSGB calculator input again. This time we're looking at 100 watts. We're using, again, 2 meter band, SSB processed. This time, because we're putting SSB processed, that only has half the energy of FM. So there's a 50% mode factor. We put in that we talk for 60% of the time. So we end up with 30 watts average, 100 watts peak. We've now got some cable, 15 meters of RG213. We've ignored other losses for the moment. And that gives us 22.3 watts average, 74.4 watts peak into an antenna. Our antenna has a 13.5 dBi gain, and that's found by looking up the antenna type that you put in there. So when we look at that, we now have 400, nearly 500 watts average EIRP and 1.6 kilowatts peak EIRP. So the 13.5 dBi gain of the antenna is increasing the fields a lot. So what we've done is to use results from detailed modeling, which I'm going on to describe, and we have come up with a figure for the minimum height for a horizontally polarized antenna at 2 meters. And that height is 3.3 meters. Now we asked you to put in the height of your antenna. 8 meters is greater than 3.3 meters, so you've hit the second green light, which is you're compliant everywhere at ground level, as the antenna is higher than the minimum required. If, however, and I should point out that The actual calculator I'm using here is updated from the one on the RSGB website, and it will be published shortly along with the guidance of the papers I'm talking about. So this is a preview, if you like. But in this case, if your antenna height is only 7 meters and your required height is 7.3 meters, then it won't give you a green light, but it will tell you what to do. It says use the calculated compliance distance to define and manage an exclusion zone, or use a pre-assessed equipment configuration. So what do we mean by that? Well, the compliance distance is 18 meters and the height for ground level compliance is 7.3. So you either need to raise the antenna and use PAEC2 to claim compliance, or you can maintain an exclusion zone of 18 meters for accessible areas, which is the compliance distance calculated from the Ofcom part of the calculator. If you know the directivity factor, you can fill in the number here. They're difficult to find, but that takes account of the fact that the calculation is being done in the main beam of the antenna, whereas at ground level, the power will be less. For example, if you had -60 dB as your directivity factor, then your distance would be halved from 18 meters to 9 meters. So how do we come up with an exclusion zone? The first step is to determine public accessible areas near your antennas. You can sketch these out, including the separation from the antenna. You can determine the compliance distances using the calculator or look up tables for your pre-assessed configurations. You can draw these exclusion zones on a little map. And remember that limits are only exceeded when there's somebody there and you're transmitting. And identify areas where the people could be and are in your exclusion zones. And record this along with any needed mitigations, and you should be compliant. Let's just give you a simple example. If you go and look up and find your antenna, there's a Luft HF antenna here, which you may be able to see on Google Earth, Google Maps, or whatever your other favorite app is. Then you can look up and use the same technique to measure from your antenna to the nearest accessible area, which in this case is a public footpath. You see that's 22 meters. So even at 400 watts, from the previous example we gave, I'm exceeding the 18 meters. So I'm compliant. And although the real compliance zone is likely to be smaller than that, I'm exceeding the simple one done by the calculator. Therefore, I'm compliant. I don't need to worry anymore. The other thing is that if there is somebody in the accessible zone or the exclusion zone, when you transmit, you can simply stop transmitting, or you can go to a different lower power mode where you know that for somebody in that position, you will not exceed the limits. So this is summarizing what I've just said. This is a map of an inverted V, trying to explain what we mean by exclusion zones. This is described in a paper called PAEC1, which you can find on the RSGB website. And it basically says that anywhere in the green area is outside of the exclusion zone. The recommended exclusion zone is the beige rectangle. The areas where you will definitely exceed and we shouldn't go are the red areas. We deliberately choose simple configurations so that you can manage them. And this is for a 40-meter inverted V, typical of what you might see in a QRP operation. Going up to something a little bit more complicated, the exclusion zone for a rotatable antenna is a cylinder. I think that's reasonably obvious that if you have an antenna pattern that can point anywhere, then it can go all the way around. The height of the antenna is a parameter you need to know, but we also provide, through some of the pre-assessed work we've done, the compliance limit, which is where above the ground you start to be non-compliant. If you think of reducing the antenna height, eventually this red circle is going to touch the ground. At the point that it touches the ground, that's the point at which you're no longer compliant. At the height we've got here, which exceeds the minimum antenna height, then you are compliant anywhere in the world at ground level. So how do we do it? Well, we use some modeling. The work's being done by a team from the ARRL and the UK. And we use NEC42 or NEC5 to model the fields. We compare the peak and average fields with the exposure limits to define more accurate and smaller exclusion zones. And the important message is if the antenna is high enough at the bottom of the cylinder not to touch the ground, then you've got compliance everywhere. Now, what you actually need to do in order to follow ICMER is to calculate the averages. So how do you do that? We actually take a 1.8 meter person and we go every 10 centimeters. So there are 18 points up there. Sorry, every 0.1 of a meter. So there are 18 points up there. And we compute the electric field, the magnetic field at those 18 sample points, and we determine the square root of the average electric and average H field squared for all the points. And then we store the maximum of the two and the average, and we compare those with the limits. There's a little trick that you have to determine which part of the body you store them on. We store them at the foot position of a person. So if the star is at ground level, then it is covering all of the average and peak exposures of a person. When you plot this out, and this is a vertical slice down through the field strength pattern of one of these simulations. So you've got the distance on the bore site of the antenna and the height of the antenna. This antenna is at 8 meters high. Then each of these contours is for a different power level. The one I'm following at the moment is the 10 watt contour. Then you've got the 50 watt, 100 watt, 200, 300 and 400. And you notice that as the power becomes higher, then the impact of reflections off the ground interfering with the pattern is raising the field strength. You also notice that the field strength is biased below the ground. Part of that is due to the reference being used as a foot. The other part is due to the field strength being higher due to reflections. If you rotate this pattern through 360 degrees, then you will see that we've got a similar pattern to the cylinder that we talked about. So if we look at that diagram again, when the rig disc just touches the ground, then the distance of the exclusion zone is equal to H min. And we have stored all of these in a table. So the only bit you need to know is what power you're using, that it's horizontally polarized. This only works for HP at the moment. And you calculate the necessary height, which if you exceed, then you are compliant everywhere on the ground. You can see these numbers are not frightening. For 50 watts, they're 3.3 meters. For 400 watts, it's only 8.1 meter. So as a simple rule of thumb, that for any frequency between 50 and 432 megahertz, if your antenna is higher than 8.1 meters, then you have proven compliance everywhere at ground level using PAEC2. So if you want to go, say, at 120 watts for 23 SEMS, you just go up to there and across there, and you end up with an answer slightly less than 3 meters. We can do the same thing for tables of stored per frequency band values for REZ, which is straight in front of the antenna, how far you need to be away, the radius of the exclusion zone. So if we come up at 10 dBi gain for the antenna to 100 watts, and then come across here, you end up with 7 point something meters. So if you stay 7.4 meters away in front of the antenna, and your antenna is more than 4.3 meters high, then you are compliant. Now, we've already published a similar thing showing the E and H fields of an inverted V. This is the equivalent diagram showing the exposure limits of the fields. Of course, the E field is maximum at the ends. The H field, where the maximum current is maximum at the center. But you notice that in this case, the 400 watt contour, compliance contour, is just touching the ground. So we took that and we made it into a bow tie. Then we defined exclusion zones for different power levels. So the blue is the 400 watt boundary. And we stuck with simple shapes, which are easy to monitor and to find. And we produced a table that said that, for example, at 100 watts for a minimum height above ground of any part of the antenna in the 80 meter band, if the ends or all parts of your antenna are above 3.6 meters, then you will be compliant. And this is all published on the website already under PAC1. It also covers the 40 meter dipole. You can see the same compliance contours. The exclusion zones, I've only shown half of it here because obviously the other half's the same. So here, your horizontal separations are shown for 40 meters. If you take the, and this is for any inverted V, or inverted, or V, not inverted, it's for any wire dipole antenna. If you can keep your center 8 meters up in the air and your ends 2 meters above the ground, as an example, then you will be compliant. And if you bring it down such that you're less than 2 meters above the ground, then you will start to see the exclusion zones. There's a list of the records you need to keep. You need to ensure your equipment never transmits above 10 watts EIRP, or how you control it, so that if it does, and it's an emergency situation, then you can record that. You can use our calculator, which is what we recommend first. You can keep the results of any measurements that you take, although I've warned you to be careful. It's complicated, and certainly don't go and buy a £20 meter, because it probably measures the 50 hertz EMF and not the RF EMF. And you can reference pre-assessed configurations. You can implement controls if your limits are exceeded. And what you must do is keep a record of whatever you do. So I had 2 questions already, which, if I may, I'll go on and answer. And then I'd encourage you to put any other questions you may have on the Q&A channel. And I will try my best to answer them.
So John, just before you answer those 2 questions, if I may, there are a couple. If Stephen 2 Echo 0 Alpha Delta Romeo would like to flesh out his question, he's made a statement he's got a loft-mounted antenna dipole for 80 and 40, but I'm not sure what his specific question is. I can imagine different aspects of that, but if you'd like to respond to that, that'd be great. Back over to you, John.
So what was the question?
That's what I'm trying to establish. I'd like him to flesh it out in the Q&A.
Okay, so you want me to, well, it may be this, maybe the same as this. Can attenuation from a building wall be included in the calculations? And if so, what are typical attenuation values for types of wall? Well, If you Google attenuation, VHF attenuation, you will find that a company called Ofcom has undertaken some research on this, and they have published some tables. You can find it there. It's a complicated thing, but you should be able to pick that up afterwards. The trouble with the tables is this is for modern building materials, and it varies between an ordinary window where the attenuation is 1 or 2 dB, to a window with film on it, to an inside wall with single or double skin plasterboard. The real problem is that across frequency, the attenuation can vary from, say, 0 up to 20 dB. And I'm not quite sure, even though you can certainly claim that your figures must be right because they're Ofcom's own figures, I'm not sure how you determine where on that you sit. So you can certainly do it, but I'm not sure what to choose. So that it does vary, and it varies from 0 to 20 dB with material and frequency, according to the Ofcom report. Have you had any follow-up on that?
I have. Stephen has come back with, so his question says, sorry, I need to scroll. I have a loft-mounted antenna dipole for 80 and 40, and then he continues, at 50 watts, what problems would I cause? I imagine an 80 and 40 dipole in a loft. He's either got a very large loft or it's not quite in a straight line. So I'm not sure how you model that.
Well, it can be done, but if you look in PAEC1, the question that the most common question we've had has been, what do I do about my child asleep in the upstairs bedroom, or I've had a loft conversion and my child sleeps there. The compliance distances that we've given in PAEC1 for the HF dipoles, if you maintain those, then you will not cause any danger to your child or anybody else at all. The alternative is, if the person is right next to the antenna, then I think you have to make sure that that room is not occupied while you transmit.
Okay, thank you very much for that, John. I'm taking.
You can, of course, take into account the attenuation of the roof tiles if you can work out what it is.
Okay, thank you. Bob Hammond expresses some frustration with the rather conservative limits, I think, of the Ofcom calculation, and feels that options for pursuing his hobby are about purchasing a larger garden or running QRP and battling with ever-increasing electronic QRM. You'll have to forgive me, John, I'm a very newly minted ham.
That's right.
But perhaps you could offer some practical suggestions to Bob regarding types of antennas for those who live in more confined spaces?
Well, let's take the first one. I mean, the reason the Ofcom and any other simple calculator, all of them have to make an assumption. And one of the biggest problems is that we start off with an isotropic radiator, and we know the power that's coming into it. Now, the limits are not in power in watts per square meter for HF. They are for VHF and UHF, fortunately. And that is no coincidence as to why the first Ofcom requirement is that you can fly above 110 megahertz, because above 110 megahertz, ICNIRP gives field power density limits in watts per square meter, and they are easy to calculate from the EIRP that comes out or comes out of the antenna. Now, at lower frequencies, say 10 megahertz, then you have a problem because you start to become in the near field of the antenna, or you become close to the antenna. And at that point, the assumption that you have the wave impedance that a number of us are familiar with in free space of 377 ohms does not apply. Now, if you know the power and you think of electronics, then to calculate either the current, which is equivalent to the H field, or the voltage, which is equivalent to the E field, you need to use I squared R or V squared over R, but you don't know what R is close to an antenna. So it's very, very difficult to use a simple calculator for field strengths or calculation close to antennas. What Ofcom have done in the first or the current version of their calculator is to limit it to lambda on 2 pi, which is the reactive near field zone. So they won't let you effectively use it closer than that by setting the limit to lambda on 2 pi. If you use one of our PAECs, then certainly the DEZ, for example, in the last example I gave, the distance of the exclusion zone from the antenna below and above the antenna, then you will find that's quite a small distance, because we have done all the modeling and we don't have to be as conservative. We don't have to rely on the wave impedance being 377 ohms, because we've actually simulated the field strengths. And as an example, the cylindrical one that we came up with was a result of 4,500 runs of NEC 4.2, looking at all ground types, all positions, all heights, and all antenna types, and then coming up with the worst case answer.
Right, thank you, John. Hopefully that goes some way to addressing Bob's question.
I'm happy to receive questions on M0JAV at rsgb.org.uk afterwards, and we'll try and answer them if I don't manage to finish them all today.
Oh, lovely, thank you, thank you. Chris G asks a question: for the EMC calculator, what's the antenna gain for the normal flexible antenna on a handheld transceiver, e.g. an FT70D? Other handhelds are available, I guess. Yeah. I could not find the information on the datasheet or the manual.
It varies a lot, but it's never it's never more than a vertical dipole.
Right.
So what we did in the calculation some way back was I put in a vertical dipole. I'll try and get back to it, and then we'll see. There must be a simpler way of doing this. But, there you go. So this was that said handheld, where we put 10 watts in, we ended up with 50, talking half the time, 5 watts average out. We put in no cable. We put in a vertical dipole because that was the maximum, 2.2 dBi, and we ended up compliant everywhere. Now, if you actually quote this calculation, you'd have to do it yourself. You can say that the RSGB calculator has proven that for 5 watts from a handheld, using the antenna that's supplied with it for all models, you are compliant with the less than 10 watt EIRP average and peak 100 watt condition.
Lovely, thank you, John. I'm going to try and roll a couple of questions into one. I have one from Bill GM4UBJ and something similar from Matthew MM0JJU. Does a compliance calculator take into effect the shielding of a building? For example, many will have a VHF antenna just above roof level on the gable end of the building. This could be just 4 meters across from the next gable and possibly an occupied room. And Matthew then says, do these limits only apply to people outdoors, or do people within buildings have to be taken into account for lower bands?
And the first thing is, if you actually run the calculator and assume no attenuation through the roof tiles or the brick walls or whatever it is, and you are far enough away, or you look up in one of the pre-assessed and you're far enough away, you don't need to worry about the attenuation of the bricks. This is the question that I answered before. It varies enormously from 2 up to 20 dB in this particular modeling that was done by Ofcom. If you can find out what it is and you want to put it in, you can actually use the directivity factor and call it the attenuation factor, because it does the same thing. You just can't use it at the same time as the directivity factor. So if you find the attenuation is 10 dB, if you put 10 dB in there, then it will give you a new distance, which will be much less than the 18 meters that this comes up with. But bearing in mind that if you used PAEC2, it was much less than 18 meters anyway. So I know this is an example for 2 meters, but I think I've answered the question by saying if you can find the attenuation that's relevant to you, and if you can't, then use a low number like 2 or 3 dB. That may give you the comfort you need.
Right, thank you, John. A question from Mike Meadows. Thank you for the presentation, John. I live in a 28 by 20 wooden bungalow. My 100-foot continuous loop is at 10 feet AGL, above ground level. I have only been running 30 watts with FT8. Is that going to be okay for me? And forgive me, I don't understand the abbreviation, XYL and near neighbours.
Wife. Ex-young lady. Something
Thank you
should
for the translation.
A lot of people have asked us to answer the question for their specific antennas, and we really don't have the resources to do it. I mean, there's 20,000 out there, but if you look at PAEC1, I'm pretty certain you'll find you're fine, even without considering any attenuation. And if you do run the calculator, which isn't that difficult, then and you're compliant with what the calculator says, then you can be certain you're compliant.
Okay, thank you.
I would be surprised if you're not running at 30 watts, but sorry, I don't carry all the answers in my head.
And then I think the final question that I can see on the channel is from John GM4UQK. When stating the power of the radio, can we take into account the insertion losses of connectors, filters, etc.? For example, a transmitter through a bandpass filter, then an antenna tuner, and an antenna tuner would have less real output power than that stated in the radio specifications.
Yes, put it in there. There's another column there for other losses. So if you've got half a dB per connector, you can put 1.5 dB in there. Not sure whether it has to be minus or not, but it will tell you if you try and put the wrong thing in.
Great.
The other thing I just want to say at this stage, currently a lot of people have been running with 10A of the calculator. We're just about to put up 11A. If you have proven compliance using 10A, then you've proven compliance, because the bits that 10A covered are still current in 11A. What 11A has done is to add the information from PAEC2, and it includes the minimum height for VHF beams, and it's just added that. All of the other stuff, although it looks different, is exactly the same.
Right, we've got another couple of questions coming in. Robin G4DNP, how do we model mag loops?
I have somebody's done it for us. I have an excellent paper. You just reminded me I need to get it published. One of our amateurs has done that. And it also gives me an opportunity to ask if anybody wants to help us in any way with this work, please. There's all sorts of things to do, from looking up cable losses for cables we haven't got in the calculator, to looking up antenna gains, or if you can use some of the necks and do some modeling for us, or write a paper like this particular amateur has done, where he's done all the modeling and written it up as a paper, then it is really a great help. We've got 3 people, Peter Zolman, Ian White, and myself, who are doing the modeling here. And we've got 4 guys in the States, ARRL people, Greg Lepin, Matt Butcher, Kai Suriak, and Rick Tell, who are all experts at it. And we're trying to do common work on the physics and then apply the different limits. So we come up with advice for amateurs on both sides of the Atlantic.
Right, thank you. I'm sure that answers Robin's question, and he'll be in touch through your email address, which is M0JAV@rsgb.org.uk. Is that correct?
Yes, it is. As I often say, M0, just another volunteer.
And then Bill GM4UBJ comes back with another question. Has Ofcom made any reference to the maximum power that your station is capable of?
No, because it depends on, in EMF terms, no. Of course, you're not allowed to use more than the permitted PEP. I have to say that, and they'll pick you up on that. But if you don't use that power and you do the assessment and validate that you never use more than a power that is compliant, that's fine with Ofcom. If for some unknown reason they come out and measure your power and find it's not compliant, then they'll talk to you and they'll find the fault in what you're doing, which may mean that you've turned the wick up when you shouldn't have done.
Right, thank you. Still more questions coming in, so we'll go to our maximum time, which I think is 17:35 UTC. Question from David M0VTG. What is happening below 10 megahertz? I'm reluctant to move my G5RV, only to find that I need to move it again later.
Well, if it's a G5RV, then you can get a good idea of what's happening by looking at Pack 1. I know Pack 1 doesn't cover antennas with open wire feeders. In fact, we have a question about that, I think. So I can't find it at the moment, but I might be able to in a minute. What's the difficulty below 10 megahertz is what I said before. It's that you are in the near field and you can't, using the calculator, simply show compliance. So what Ofcom have done in the short term is to limit you at lambda on 2 pi, the near field distance. If you can meet that, great, you're fine. Let me just quickly, I may go one step too far here, but this is ICNIRP 2020. And one thing that comes in up to 10 megahertz at ICNIRP 2020, which isn't there in 1998, is a peak limit. And you can see that the peak limit for the electric field strength is much lower than the corresponding limits for the average. So you've got the average 30 minutes is here, and that carries on as a straight line. And similarly, you've got the average exposure for 6 minutes, and that carries on as a straight line. But because the peak limits are lower, below 10 megahertz, the calculator has to work in individual electric fields, individual magnetic fields, and the limiting factor is the electric peak field. We actually have a prototype of a calculator which we've shared with Ofcom, which does do the calculations down here, but it still has limitations. It probably can only be used from about 80 meters, 3.5 megahertz up. There is more time. We are working hard. There is another issue when you go below 110 megahertz, which Ofcom are working on and which some of the experts in our group are working on, and that's called current limb currents. And when you stand on the ground, then the peak field at those frequencies can in fact cause limb currents above levels which ICNIRP 2020 recommends. So it's not simple, but we are trying to help Ofcom, and I know that they're working on it as well. And we hope to have information before May next year, which is when you need to go below 110 megahertz, and November next year, which is when you go below 10 megahertz. But we've done some of that work in Pack 1, which is on our website.
Right, thank you, John. And then there is one question from the club itself, which I guess we ought to address. Otherwise, my membership might get suspended. The question is it fair to say that anyone running QRP power levels into verticals and dipoles is going to have to try hard to be non-compliant?
Well, if I can add to that one other thing that I haven't mentioned in the presentation, which is we actually, there is a requirement for touch currents as well. So somebody can touch your antenna. We get around that very simply by saying, keep people 2.4 meters from your antenna. So if you add that condition and you stay 2.4 meters away, then I'd like to set a little competition. Can somebody find me a QRP configuration which is non-compliant?
I think that's a lovely note on which to, a lovely challenge on which to finish a really interesting presentation, John.
And please remember, I think you've got shared. Have you still got my screen shared showing you?
We have, yes.
That page, it's rsgb.org/EMF. Couldn't be easier. And it will take you to this page, and everything you need to know will be linked via that page.
Okay. Well, John, I think it just remains for me to thank you on all our behalves for your time and effort that you've put into this presentation. It's been really interesting. I hope we've managed to answer as many questions as possible in the time, and I'm sure you will have quite a full inbox when you get back on Monday.
Well, we've had over 6,000 queries already. The other thing that I should say is that watch out for the November RADCOM. We're working on an article for that. EMF compliance checks for frequencies above 110, and that's got all of the stuff in it that I've shown you here. So if you like, that is in draft and it contains the same material. And also watch out for PAEC2, which is a 70-page document, which is all the details of the methods and the calculations behind that. And that will be on the website, hopefully in the next 2 to 3 weeks.
Thank you very much, John. I'm now going to stop the recording of the presentation as I think we've got to the end of our time, and I know that the next one needs to begin shortly. But thanks very much, John. Much appreciated.
Thanks, everybody. Have fun.